right. In all seriousness, I appreciate, I asked John when Teresa walked in, I said, what's the over-under? I said, is she going to be the only one who shows? And he didn't know one way or the other. So, that's good. That we got, pretty close to, well, really half the class. So that's good. It's more than I thought would come on a day like this. Well, and Stefan's like 3 people. So you're right. Yeah. All right. So what I want to do is go over the next 20 or so pages of this handout, the big handout that I gave you. So I want to get to about page 152. Then we're going to go and literally get on the system. So I'll bring the Macs out. But we're going to sit there and you're going to see what a playground is and how to use it. All right? We left off on this last time. We started to go through it, but then, I think this is a good place to just, step back a little bit and talk about it. So hopefully this makes sense to you that right now, if you look at this particular function that you see here on page 128, remember when you create a function, it's func, F-U-N-C, which is a key word, as you can see by its coloring. And then in this case, the name of the function is add2ints. The function takes 2 parameters, an integer referred to as a, an integer referred to as b, and as you can see there, it returns an integer. Boom. So hopefully looking at that, that just makes sense. All right, again, the syntax is a little different. We're not used to writing it that way. We're used to writing function, etc., and some of the other stuff. But the idea is the same as far as what you've done before. All right? All right, they go through it in a little bit more depth. It says you can use function types like any other types in Swift. For example, you can define a constant or a variable. All right, the b of a function, and assign that function to the variable. So look at that, because that looks a little different, but it's going to get into the idea of closures that we're going to get into in just a couple minutes. As it says, this line that you see right here in blue, as they mentioned there, it can be read as define a variable that's called math function. All right, there it is. As it says, it has a type of function which takes 2 integers and returns an integer. And then set this new variable set this variable to refer to the function called add2ints. And again, it's like, what? And what they're saying is, when you use this now, you are able to actually use a function as though it's a variable. All right? So this is creating an actual new variable right here, and it's assigning this to that. So it's defining a variable, as it says, called math function. And add2ints is just what you're assigning this to. All right? So it says now you can call the assigned function with the name math function. All right? What's cool about this is all this says is, well, what do you want to do right here? Well, notice that add2ints is what we did up here, right? So now, since we're assigning it to this, okay, that's going to go, and when you call it, it's going to add 2 integers, just like it says. But now in the next line of code, so play computer here for a second. Let's put all this stuff in there that they have. So we've got 2 functions right here, add2ints, which just pass in 2 numbers and you add them together and return the result. Multiply 2ints, which again, you pass in 2 integers, you multiply the 2 by each other and you return the results. Then what they're doing is they first come in here and they go, okay, now math function is now, it's a shortcut for lack of better words, all right? And what it says is now when we call math function, what it does is it calls this. And it's as though we call this, and it's this right now, putting it in like this. This is the same thing as if we said print line, result, and instead of saying it like that, it's like we went in there and said add 2 ints 2 3. Doing the same thing. So, I mean, a natural question would be, okay, I get it. So, why? What you're doing is you're allowing this to become an alias. And if you've got all sorts of different functions that you're writing, as long as they all require 2 integers to be input, and they return an int, what we're doing is, for lack of better words, is we're making an alias. Now, do you ever have to use this? No. But what it's showing you again is the fact that you are able to use this function right here is appearing on the left-hand side of an assignment statement. This is one place where they changed this language where it's getting to be more JavaScript-like I mentioned last week, in that you can take a function and put it on either the left-hand side or the right-hand side of an equal sign. That's all. I mean, we could have come in here instead of doing it like this, you know, again, with all this stuff that's in here. You already saw this, and I said this is basically right here the same thing. All right? We still can come in here and say this. Var result equals add 2 ints A, B. All right, I'm sorry, 2, 3. And that's going to give you the same answer, but it's going to put it in results. So for right now, you might look at it and go, okay, I even sort of get what you're saying. I just don't see what it buys me. Then don't use it. But the idea is it's another thing that's available to you to use. All right? We'll get into this stuff in more depth next semester. Okay? I've gone in and I've written the first 2 programs that we're going to do. We're probably going to end up doing them next semester. It's, many people would find this, something like this, a little easier to read. Plus, like I said, you can sit there and you can keep calling math function. But all I have to do is keep assigning it to different things. All right, it would be, I could literally create my own calculator pretty easily doing this. All right. It says you can use a function type such as int as a parameter for another function. What does that mean? Actually, believe it or not, you already know what that means. Because when you look at it right here, this isn't a good, actually it is a good example, but let's go back to the one we just looked at. All right, what are we doing right there? All right, and I'll answer the question. What we're doing is we've got 2 functions, right? We've got the math function embedded inside of the printline function. Would you agree with that? So you're going to call the math function first, and the result of that is going to be one of the things, basically, that string is going to be, you're going to say print line result, and then the return value. All right. So all they're saying here is it's the same kind of thing. But in the past, it's what we're doing right now. All right. It says, here's an example to print the results of the math functions above. All right. As it says, this example calls a function called print math result. It has 3 parameters. The first is going to be math function. This right here is the first parameter to this function. That's the second parameter to this function. That's the third parameter to this function. No, what that's going to end up actually printing right there is same thing, result In this case, 8, because it's going to add together 3 and 5. But you're passing your own function to another function. All right? There are other ways that you can do this. They're showing you another way of doing this. And I think the reason that they're doing it like this, I didn't write this thing, but I believe the reason that they're showing it to you now and the reason that they're showing it to you like this is because they're going to get to closures in just a couple minutes, which uses a lot of this stuff. And hopefully then you start to see where you can really save some code. Okay. All right. As it says, you can use a function type as the return type of another function. You do this by writing a complete function type immediately after the return arrow. It says the step forward function returns the value that is 1 more than its input value, and the step backward returns a value that's 1 less. Now, that said, you're looking at this, I don't know about you, but I'm looking at this, I'm saying, okay, this is fine. I even sort of get it, but I still don't, why don't I just return whatever this I passed in plus plus or minus minus? And you can. They're just trying to show you yet another way of doing it, right? Or that it can be done, I should say. You can have functions nested inside of other functions. That can be a little confusing. It says you can rewrite this choose step function to return the nested functions. Well, the bottom line is this. Here's the function. Starts there, it ends there. So it's called choose step function. Inside of that function are 2 other functions. And in English, what it says is you call this. If you pass in, if you step forward, it's going to return 1 more. If you pass in step backwards, it's going to return 1 less. All right. So they're embedding functions within functions. The other thing too is, just so you know, they don't show it here in this example, but if I'm in here, so I guess I better just copy all this here. I just want to make sure you do understand this. So if I come through here, that's pretty ugly, so we can pretty it up a little bit. This, I don't know if this makes it easier for you to read or harder for you to read. But for me, it makes it easier because now it's written more procedurally, more the way that we're used to doing things. So to me, it makes it easier to read and understand what's going on. In English, what this is saying is, I've got a function that's called choose step function. All right? And it's basically what's going to happen is I'm going to pass in 0 or 1. If I pass in 0, I'm going to call this. If I pass in 1, I'm going to call this. All right? Or maybe I guess it's vice versa. All right? So if backwards is true, we're going to call this one. Otherwise, we're going to call this one. All right? Again, are there other ways of doing it? Of course there are. Okay? But again, the other thing too is if we were to come in here and say this, var x equals 27. That means nothing. I just made that up. The point is, if I create that variable inside of here, that variable, even though it's created here, it's available inside of this function or inside of that function. But any variable that I create in here, that's only available inside of this function. It's unknown outside of it. Same thing if I come in here. That's only available inside of that function. All right. And again, I'm not going to say, but this stuff's easy. I mean, I'm sure you totally understand it. I understand it. I understand it better than I can explain it. But I think if you take a look at this, hopefully at least it'll make some sense. All right. If you haven't had a chance to look through it, I mean, by the end of this, about 10 or 15 minutes, we're now through the first third of this handout. right? And if you haven't read any of it, you should. Because next week, what we're going to do is we're going to go over the second third, all right? And that's on using classes. Now, I'm not saying that we're going to go through 463 pages or whatever the heck it is, and we get done and you're going to go, that totally makes sense. But the idea was to go through what Apple provides so that come spring, you know, once we start learning this, it'll be relearning it, and hopefully it'll make some more sense. That's it. All right. Closures are self-contained blocks of functionality that can be passed around and used in your code. So in other words, closures allow you to use the equivalent of a function as a variable. All right, but they're more generic in nature than variables. And this is a word. If you've never heard this word before, it's a word you should look up. Lambda. All right, because Java allows for lambdas, although we didn't get into it in Java. JavaScript allows lambdas, and what lambdas are closures in this language. They're self-contained units of code. They're done differently. The syntax is different in different languages. But in some ways, the reason that you create closures, lambdas, your own functions, etc., is if you find yourself doing the same kind of operation in code a lot, it doesn't make sense to keep coding it. It makes sense to go and grab it and put it in some kind of a library and then call it on an as-needed type of basis. And that's what they're getting to in here. So as it says, closures can capture and store references to constants and variables from the context in which they're called. And notice, Swift handles some of that for you. And I'll take your question in a second, but I will tell you, this example, the example itself, what's happening is unbelievably easy. Going through the code is not. It's probably about the next 10 pages or so. So you've got to read it and really take a look at it before hopefully it'll start making at least a little bit of sense. Yes. Well, most of the time what you find, it depends on what you're doing. All right, for instance, when I was at AT&T, we did a lot of database operations. So they ended up writing, they meaning the people at AT&T, there were a whole ton of libraries that had a bunch of stuff available for us. I had to call it based on what I needed at the time. You know, it's kind of like if you could write yourself a generic sort routine that would sort anything. An array, a dictionary, anything of any size. And it didn't matter what the type was. So you could pass in words. They had to be the same type. So you could pass in words, numbers, letters. It didn't matter. Well, that would make sense to me to write it once and then call it whenever I needed it. And let the system figure out most of the work, you know, for me. It would be, in other words, it would be done for me. And that's what they're getting to here. Well, it's even more than that. No, we didn't have anything like that. No, not at all. It says global and nested functions are actually special cases of closures. Closures can take one of three forms. Global functions are closures that have a name and do not capture any values. Nested functions are closures with a name and can capture values. Closure expressions are unnamed closure. Well, that makes a whole hell of a lot of sense. So let's look at the example that they put in here. Like I said, the example is really simple. It's a simple sort. But they keep refining it and refining it and refining it. So when they get done, what they do as several lines of code, they basically write as a line or two of code. And to kind of get back to the question that Mike asked, no, what programmers are always trying to do is not reinvent the wheel. And if somebody's created something and you can use it and it's been tested, you want to use it. You know, you've always got plenty of stuff to do as a programmer. I don't care what anybody says. If you don't, all right, then probably you're not just a programmer, you're something else. All right, but most programmers at places of any size, like I said, you know, where Zach's working right now and where Doug works, all their programmers are on, you know, like 60 or 70 hour mandatory overtime. They have plenty of work to do. So as it says, closure expressions provide a way to write inline closures in a brief focus syntax. So let's take a look at what they have here. All right. It says Swift's standard library provides a function called sort, which sorts an array of values of a known type based on what you provide to it. Once it completes, as it says here, sort returns a new array of the same type and size as the old one, but they're in correct order. Okay. So if we had this, if we had right here, if we had this thing with names in it, let names equals Chris, Alex, Iwa, Barry, and Daniela. All right. Well, you should be able to look at this and know that when you get done, what? We'd have Alex, then Barry, then Chris, then Daniela, then Iwa, because that would be in sorted order. All right. So as he says, the sort function takes two arguments. The first argument it takes is an array of a known type. Well, we now have the array. All right. A closure that takes two arguments of the same type as the array's contents and returns a bool. So what this is going to do as you go through it, all right, is it's going to figure out, it's going to keep comparing everything. And by the time it gets done, for lack of better words, it's moved Alex to the beginning. Then it compares it again, and it moves Barry second. Then it compares it again. It does Chris third. Then it does it, etc. But it does that for you automatically. Now, I want to show you something that you may or may not have noticed or known about. I don't know if I ever showed it to you or didn't show it to you. All right. They talk here about JavaScript's array sort function. So when you do this, you've got an array with banana, orange, apple, and mango, and you call fruits.sort. Boom. Comes back and it does this to you. What you think? The problem is instead of having this, so instead of having that, what if we had in here what if we had that? I know fruits would be kind of a stupid name, so let's change it to numbers. Well, the way that JavaScript works by default is that what that would do is it would give you what? 143, then 18, then 2, then 73, then 89, and then 9, because it does a lexicographical sort. And it says, well, that character is first. There's a 1 in here. Oh, that's the smallest. Nope, that's the smallest. So then it compares these two. And it compares the 4 and the 8. And it says the 4 is smaller. So it's done comparing. So when it does a lexicographical sort, that's what you get. Does that make sense? No, it is actually, it is an ascending order. But it's not numerical ascending order. It's in lexicographical sorted order. So what it says is when you compare these, all you do is you keep looking at the first character. And if the first character is the same, you look at the second character. So notice what 1, 4, and 1, 8. So that actually is in order. So that's where this screws up. So when you go and you run it, when you run something like this in here, all right, it says this is what you have to do. Function AB return B minus A. What that literally ends up doing in this case is what you'd want it to do. So if we do this, so now if we do this, all right, as it says, that's what the results will be. And hopefully it makes sense to you. If we do this, now the results are going to be what? 1, 5, 10, 25, 40, and 100. Does that make sense? But it does all that stuff, and for lack of better words, it's like it keeps it in a loop. That's what it's doing. And the reason I'm mentioning that to you is if you look out here on W3 Schools and you just type in your JavaScript sort, you'll get this. All right, and the reason I'm telling you that is that's what they go through in here in the next several pages, is how basically it's done in Swift. All right, so they're going through the same thing. So it says one way that you can do this, all right, is to go in and pass it in. So in other words, it says if we did this one greater than that one, notice reverse now what it does. And we should be able to come in there and say S2 greater than S1, and it would put it in ascending order. You got to look at when you compare two values, one of three things happens, right? The first value is bigger than the second value is bigger than the first, or they're the same value. That's the only three possibilities you have. All right? So as it says, this will reverse it. There's nothing special about that name. They called it backwards because it sort of made sense. But you could have called it Ralph and it would have worked exactly the same way. All right? So then they go through here and they show the syntax for this. Like I said, this is fairly advanced. All right, just so, I mean, if you say, well, good. Well, it is. All right? And it's the kind of thing you can write yourself an app and never have to use it. But what it can do is two things. It can provide less code for you. That's a good thing always. And it can make the app run faster because there's less code. So if you're writing yourself an app where maybe it was a game or something and it's not reacting very fast to user input or whatever, these are the kind of things where you would consider making changes. So you get some really butt ugly syntax here. So earlier they wrote this, func backwards. All right, you should be able to read this now. All right, it's a function. It returns a Boolean. There are two strings passed into it, and it's called backwards. All right. So notice what we're doing in reverse. In reverse, rather, we're passing in the array called names, and we're passing in that function. So that's going to go in, and it's going to take those names that we saw here that weren't in any order, and it's going to change them to reversed order. Again, if we put a less than sign here, we'd have them in ascending order. So we could write another function and call it forwards. Does that make sense? So what they're saying is rather than writing this as 1, 2, 3, 4 lines, we can go back and they're starting to cut it down. The syntax gets more compact because you're grabbing stuff and throwing it all on the base. It's kind of like when you use a for loop as opposed to a while. With a for loop, you've got all three of the things on the same line. But with a while loop, you've got one line that does the initialization, one line that does the test, and one line that does the incrementing. All right? Some people don't like to use the while loop because there's too much code. That's why they use the for whenever they can. Other people are like, no, that makes more sense to me. All right, there really is not much difference between using the two of them. So now notice what they say. Now, they've cut that down here to just a single line. All right. And it says this illustrates the overall call to the sort function has remained the same. One thing you have to realize, because we're going to go into this in just a second. All right. We've talked about this before, but I want to say it one more time. That if I do this, as opposed to this, those are both called inferred type checking. Right now, this, right here, this, the system looks at it and it says, okay, you wrote it like that, but what you really meant was this. And when it sees that, it says you wrote that, and I think it defaults to a double. I could be wrong. I'm not sure if it defaults to a double or to an int. But you see that? All right. The reason I'm telling you this is I've been reading a lot of articles on this lately. Some books say do it like this, and always let the compiler infer for you. It's a little bit less writing a code, etc. Other ones say no, leave no doubt, do it like this. But if I do it like this, and then a little bit later on in my program, so I just got 3 dots, if I come down and I say salary equals 50,000, 5,000.23, I'm going to get an error there. Does that make sense? Regardless of which of these 2 ways I do it, the system thinks only ints can be in there, and I put a value in that's not an int. Does that make sense? So if you want to leave no doubt, explicitly declare the type. And remember, when you do this, it's colon, and there has to be a space in there. All right, followed by the type. It looks a little goofy, because I don't know about you, but I'm used to seeing stuff like this in C. Int salary equals 43,000. And for this, double salary equals 43,001. I'm used to that. In fact, I'm used to this and this. All right. So what they keep doing here is they keep taking this and knocking it down more and more. And here they've said, well, you don't have to even say that it's a string, because you can infer it by what gets passed in. So now they made it even smaller. So all they keep doing in here is cutting down what they're doing more and more and more. So now notice what they've done. This is the same thing that they wrote before. So hopefully you start to see when you do this how much shorter it actually becomes. And they say, you know what, if that's not enough, how about this? You could make the case and say, well, geez, you know, as I'm learning this, if you're going to force us to use these, for example, then you know what, I'm not going to write it with a shortened expression. I'm going to write it real big so it makes sense. Then that's what you should do. I would never force you into using some code like this anyway. Yes. You mean the parens? No, the parens would be required here. No, the only time that parens are not required is like if you're using an if or a while or a do while, etc. All right. Yeah. Then there are a lot of people then that say, if that's the case, then just use them. Just do it. Write the code the same way you used to. Even in their stuff that's in here, they'll tell you, if it makes more sense, keep putting your semicolons in, keep putting your parens in. It's not going to hurt anything. Right? All right. I'm just going to stop it there. I mean, that's enough. And like I said, after a while, it makes your head hurt. Oops, went the wrong way. All right, the last thing that we'll talk about real quick, and then we're going to get on the system, are enumerations. When you create an enumeration, here's an example. So if you look at this enumeration right here, all right, you may end up doing something like this to pretty it up a little. Okay, but now hopefully you understand this. Compass point can only have 4 values: north, south, east, and west. There's no northwest, there's no southeast. You'd have to add those as other enumerations. Also, if we did this in C, north would have a value of 0, south would have a value of 1, east would have a value of 2, and west would have a value of 3. But with enumerations in Swift, they have no arithmetic value unless you give them one. They're just things that stand on their own. All right? And that's what they talk about in here. says, unlike C and Objective-C, enumeration members are not assigned a default integer value. Instead, they're values in their own right. So this isn't that different from one that we looked at a little bit earlier with the planets. All right. So that would be an enumeration. Planet could hold the values Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. All right. Notice they're pretty up to date. They don't have Pluto in here. Yes. We're going to look at that in just a second. We're going to look at it in just a second because the syntax is a little goofy. We're going to get there in just a second. What, your question? No, it's in this case, they're using the enumeration in a case. You don't have to. It's quite often going to be used in there because, again, it makes your code more readable. Okay? If rather, if you had an array, let's say that these were in an array. All right, and to be honest with you, I probably wouldn't use them like that anyway. I'd probably make this a dictionary, myself. All right, that we started talking about. But notice, you asked Mike how you use that. Here's how. Far direction ahead equals compass point. That's the name of the data type, dot west. And again, the IntelliSense should kick in right there. So when you type in compass point dot, you should get the IntelliSense that's got in alphabetic order. So it'll be east, north, south, west. Let's just put it this way. You can use them pretty much like you did C enumerations. All right? Yes. All right. You can still assign them a value. It doesn't seem like it's done as often in here because you don't have to. And also notice direction to head equals dot east. Why don't you have to say compass point dot east? Because you already set it up here. You still can. It's not going to hurt anything. So if you think that's really ugly, then you can write compass point dot east. It won't hurt anything, but it's a shortcut. As it says, it's inferred because it's already known. Now it says this makes for highly readable code. You may disagree with that and say, no, it doesn't. It makes the code harder to read. Then don't do it like that. All right? You've got to realize that this is me speaking. This is not out of any book or out of anything. This is me speaking. But I think Apple is trying to sell this to a new era of coders. And they're saying you're going to write less code. It's going to be more type safe. It's going to allow you to do things you can't do in C. It's going to allow you to do things you can't do in C Sharp or C++. You still can use pointers, but you don't have to, and they're not nearly as hard to understand now, etc. I don't think anything that you do in this is easy, but I would say that this is easier than the C equivalent. Right? See, the thing is, people keep bashing C, and they keep saying, this language just sucks. But the thing is, it's almost 50 years old. It's 46 years old. And guess what? It's still one of the most used languages. What does that say? It's pretty damn good. All right? But now they're trying to make it easier to write things that are more C-like. Right? So I don't know if that answered what you were saying, but that's the way I'd put it. So here's using it inside of a case statement. But again, you don't have to. Here's, again, some of the examples that they give in here are just, I'm sorry, they're stupid. Because you're going to have mostly harmless for Earth and not a safe place for humans for any other planet. Okay. If I'm going to do that, then why do I need to do that using a switch? I could just do it with an if, saying if some planet equal Earth, type of thing. Else, do this. But I think they're just trying to show you that it's a way you can do it. That's all. All right. Then we're going to stop right here because now they talk about this example with a barcode, and it's a goofy example. All right. Yeah. No, they're using that as an example. All right. It's not that they're doing anything with QR codes. No. And so we'll come back to that. And then we'll get into the classes stuff next week. All right. Now, We're going to actually take a break a little early in about 5 minutes. So if you just give me a couple seconds, this is what I want to show you. There is a folder out there, as always, out on the P drive. You know the drill. So you go out there, and there's a folder with today's date, which is 11/24/2014. I want to take a couple minutes and talk about what's in that folder. All right. Then after the break, I'm going to switch over to the other machine and start taping over there, but I'm not going to tape long. All right. I'm going to go over this first tutorial that I handed you all out a hard copy of. All right. And I'm going to go over it fairly quickly and ask you to play with it. All right. I think you're going to get more out of that than out of me talking. So if we looked at that, again, that was it. So if we looked at what's in that folder, it's called Ray W, because he's got a series of tutorials, and I went through them last week. All right, first couple I've got up here already. We're only going to have time to go through the first one today. But he's got a couple other things out here. This is the first thing I want to show you. This is, if you go out to raywenderlich.com, literally what I've got here is 5 pages long. Did you hear me? It's 5 pages long. I cut it down because he has 50 pages worth of tutorials. 50 frigging pages worth of tutorials. Notice here, he's got a bunch of them on Swift. This is going to get into much more depth and breadth of coverage than we'll be able to do in a semester. So I wanted to show that to you, so if you have an interest, you'd be able to go look at it. All right. Then after that, this is a cheat sheet for using Objective-C. All right. And I'm not going to worry about that right now, but here's his Objective-C. So for complete beginners to Objective-C and for experienced programmers but new to Objective-C. Here's his iPhone. Here's his iOS 8 stuff. And then finally, because he's not as big an Android guy, there's his Android stuff. So I just put it there because I'd rather give you way too much and say if you ever get some time and you want to look through this. Because this is a decision, believe it or not, we're coming close to this. All right? Because when we come back after the break, you're in your last semester. So ideally, you're starting to think of where would I like to try to apply for a job? And what kind of skills would I have to show them if I want to get hired? Well, again, if one of your goals, or let's say your goal is you want to be an Android developer, then I'd say for next semester for the 152, 156, that Android class, and maybe for your 152, 164, the design and implementation projects or the DIP class, I'd work on an Android app. And if it's an iOS app, I'd work on an iOS app. All right, and if it's no, would rather work in PHP, then I'd work on a PHP app. All right, and if you go, I don't want to do any of those. I want to do some web development stuff. We're going to handle some of that next semester too. All right. So that's the first one that's out there. And I'm not going to go through that any more than that, just to show that to you. That's part 0. Part 1 is the handout I just gave you. Part 2, he goes and writes he goes in and he writes actually in part 1 here, he goes in and he creates a class using Playgrounds, and we'll see this after the break, that's got no GUI in it whatsoever. But you don't even need to create a project to get this to run. And it's that tip calculator. Then he goes and he writes the tip calculator again, and he writes that using GUIs. This is what we're going to do on Wednesday. And some of it's going to be review. But I really like the way this guy does things. All right? And I'm not sure what we'll be doing the next 2 weeks, but we'll see. Okay? I'll tell you quickly the 2 programs that I've written in Swift. All right? First one is, we're going to literally, it's going to be real simple. All right? And I could do it on the board, but that wouldn't help people who are watching the tape. But we're going to literally just bring up a screen. And on the screen, what we're going to have there is a little label that says something. I'm not sure what, but the idea is you enter in your dog's age. Okay? If you don't like it, Teresa could enter in her turtle's age. It doesn't really matter. You could change it to do that. But the idea is, the claim is that a dog is every one dog year is the equivalent of 7 human years. Now they've changed that over time where it also depends on the breed and the weight. I don't care. We're going to assume that. So we'll have a little picture of a dog, and it's just a cartoon one that I found. All right, we're going to put that out there. So if Kelly runs it and he puts in that his dog is 10 years old, it'll come back and say, Kelly's dog is 50 years in human years. That kind of an idea. Okay? Pretty simple, but we'll put stuff, we'll create it first, then we'll think about all the things you wouldn't want to do. Like when it asks for the age, leave it blank. When it asks for the age, write none of your damn business. When it asks for the age, put in a negative number. When it asks for the age, put in 1,000. All right? And then after we do that, we'll go back to one of our old friends, the prime number program. All right? Where we'll write a prime number program in Swift. Okay? And we'll do that. And we're going to do that next semester before we even open up the book, the Dytel book, especially if the Dytel book isn't ready. But we're going to do that because chances are pretty good next semester that at least Travis will be in this class. Mike Rates might be in this class. All right? And there might be people in this class that have not taken the C class yet. So I'm going to go at it kind of slow the first couple weeks. All right? Just so you're aware of that. All right. Then if you look at here at the end of this, the last 3 things in this tutorial, because there's 6 parts, part 4 that's in here, boy, I don't know about you guys. I do not like Word 2013 because there's that. It's all sorts of stuff. It doesn't like it when you open up too many files. It just complains about all sorts. See what happens when you try to open up too many files? It doesn't open them. I would, but I don't think we can. No. All right. So the tutorial 4 are some facts on the language. I'm not going to go through any of this. If you're interested, go look through it. It's very well written. I have read it. All right. Then tutorial 5. What this is an Objective-C programmer went back and did a review of Swift. Get the idea? So it goes back again, when Mike, when you mentioned that before, is it, because it's going to be easy. No, but you get an Objective-C programmer's take on whether or not doing something in Swift is easier than doing it in Objective-C. All right, and then finally, part 6, this is his own. He's got this style guide. Again, this is something he recommends as far as how to name things, etc. All right, I'm not going to force you to go through that and do it that way, but the thing is, this is somebody who's been doing it for a while, who's giving you suggestions on the best way of doing something, so I think it's a good idea. Yeah. Yeah, it is. The code becomes much easier to read. All right. So after the break, this is what we're going to do. If you take a look up here, I'm not going to go through any of this, but he talks about playgrounds. We're going to create a playground as soon as we get back. One of the things I got to do is just get the machines out. You don't have to type in what he does, but you can if you want to. All right. The idea is you're going to type something on the left-hand side. For example, you'll type in let tutorial team equal 56. And that'll be in like a white color. Then in gray on the other half of the screen, guess what it'll say? 56. Then you'll say let editorial team equal 23. That'll be on the left-hand side. On the right-hand side, it'll say 23. Then you'll type this on the left-hand side, and on the right-hand side, it'll say 79. It'll actually do the add. All right, so we'll talk about that in playgrounds. We already know the difference between using var for a variable and let for a constant. I've been trying to harp on you explicit versus inferred typing. There's explicit, that example, that second example there, that one's explicit because you are explicitly telling the data type. That first one is implicit, or sometimes called inferred data typing. And they show you it in float and doubles, with booleans, with strings, etc. All right? Then they jump into classes and methods. And they say, hey, let's build a quick little calculator. All right? Now, if you don't want to type any of that code in, You don't have to, because one of the things, if you'd all look up on the screen here just for a second, that is in this folder, if you copied it, notice that there's one, we'll have to take this, I'll have to take it, you'll have to do the same. And you'll have, it's tip calculator, so you'll have to extract it. And if you extract it, not big, 70K is, today, anything 70K is not big. All right, so that's the playground right up here. So if I click on this, notice it just says here tip calculator, and there's tip calculator model.swift. It's one of the things where it'll be different. That's everything. So you can copy it from in there if you want to, and boom, just paste it in. So we're going to take a break. We're going to come back at 5 after 4, and when we come back, we're going to go in and we're going to create a playground as a class. What's that? Yeah, I've got a jump drive right here, and I've got it on if you want to use that. That's fine.